In this lecture, we are going to talk about the idea of interrupts and why we need them. If you already are familiar with the concept of interrupts, you could skip this lecture because this is not limited to 8085. It's about the general idea of what an interrupt is. So we've been mentioning this that the computer is a combination of a CPU, memory, and input-output devices. And a CPU is the processor, is the brain of the computer, but it is not a smart, meaning that we put it in an infinite loop. Inside the CPU, we have a set of registers, one of which is called PC or program counter, or sometimes instruction pointer. The job of this register is that it would hold the address of the next instruction to be executed. That we just give the address of the first instruction of a program that we want the CPU to execute inside the PC. The CPU would look at that address, meaning it would put that address on the address bus, would select a memory cell, gets the content in that memory cell, fetch those content, put it inside IR, would decode it, execute it, would move to the next instruction by incrementing the value of the PC, and this would go on and on executing the program that we have. But sometimes we might want other programs to be executed as this program is getting executed, or some other device needs the attention of the CPU. As a general example, let's say you are watching a video on a player, or maybe you have a notepad file open here, and then you as the user would press a key. So the way that the CPU and input output devices like keyboard and mouses are working, let's say that keyboard is connecting to a pin of the CPU and the mouse is connected to another pin. And the way that these pins on the CPU work is that if these pins go high, the CPU, the value of the PC would be changed to a specific value. As an example, let's say that if this pin goes high, if we have a high pulse on this pin, the value in the PC register would be changed to 0034 in hex. So this is half of the meaning of an interrupt. The value of the PC would be changed, which means that another program is going to be executed. So right now, let's say that first, when I say that you were watching a movie or have opened the file, it means that a set of instructions were getting executed. First, it was 1002. The contents here would be fetched inside the IR, would be decoded, executed. 1003 and 4, you are seeing the result as playing a video or just browsing a file in your file editor. Now you are here, the execution of 1004. When you are, the CPU is in the execution of 1004 address, it means that the PC is pointing to this location, so that when this instruction is completed, then it would move the value inside this address. So the PC value is has the content of 1005. Sometimes we say, we refer it in this way, that the PC is pointing to the address of 1005. So right now, a key on the keyboard has been pressed. A high signal, the keyboard would send a high signal on this pin, would cause the value of PC to be changed to 2034. First of all, you'd want to write a program starting at 2034 that it would handle the pressing of a key on the keyboard. That you write a function at 2034 onwards that would check what key has been pressed and would do the corresponding actions to that pressing of a key. Maybe it would just find out that the key that has been pressed is G, and then it would send some data to the monitor, or the interface between the CPU and the monitor, the graphic card, causing it to turn on a set of pixels that you see the result as G on the file. But what you are caring right now is that you should write the corresponding instruction of how you want a pressing of a key on the keyboard to be handled starting at that address. We call this function the ISR, or interrupt service routine. That means that when an interrupt, a specific interrupt happens, I want this function to be executed. Interrupt service routine. Now, let's say that the pressing of left click of the mouse, because the mouse is connected to another pin, it would jump to a location like F000. So you'd want to write another program starting at that. So the ISR of the mouse is different with the ISR of the keyboard. The manufacturer of the CPU tells you that if this pin goes high, then it would jump to this location. If this pin goes high, it would jump to this location. But the way that you connect different elements to the CPU would tell you how you'd want to write your ISR, or where you want to write your ISR, the corresponding function to each interrupt. So there is one problem though. If the CPU, the value of PC has been changed, and the CPU is pointing to this location and fetching this instruction, let's say it would execute these instructions one by one until it is completed. Now, how would it know to go back to 1005? Because we don't want it, when the execution of this ISR is completed, we don't want it to just go on and execute the next memory cell or the instruction in the next memory cell, while you don't want that. You want it to go back to where it was left off, so you could see the rest of the movie or the rest of whatever you were doing. Therefore, you need to somehow save this address. One way would be you say, well, I say move whatever, like 1005 to a location, to a register to use it. The problem with that is that you are filling a register that you can't use later. So the best, and also you don't know where what a specific address that is when the program is getting interrupted. So what you want to do is to use the stack, what we mentioned previously. You'd want the CPU to do this. You'd want the CPU to say, when an interrupt happens, the CPU to execute something like push whatever is inside the PC and then jump to the like 2034. You want these two instructions to be executed by the CPU when an interrupt happens. We don't have any instruction called push PC in the ISR of the 8085, but this operation is part of another instruction that we call call ADDR. What this does is that it would first push whatever the value is inside the PC, and then it would jump to the ADDR, just like when we talked about push and pop, and we said every one of them includes micro operations, like push PC would be decrementing of SP and then doing a memory write. The same thing happens here. The call is formed of two smaller operations. Each one of these operations would be formed of a smaller, yet a smaller operations than that. So what call ADDR does is that it is the beginning of the instructions of the execution of an interrupt. The computer is executing a set of instructions or a program, an interrupt happens. When that interrupt happens, a call would be executed by the CPU, meaning that the value of the PC would be pushed on the stack. The PC would be changed, meaning that the CPU would jump to another location. The instructions there, which would be the instructions as part of the ISR of that interrupt, would happen. But after the execution is finished, you would want to say pop to the PC, meaning that whatever is on the top of the stack, which was the PC, because you'd want the stack to be, let's say, how do I say this? You want a stack to completely be the way that you left it off when you started the ISR. If you are using the stack in between, as we mentioned earlier, you'd want to just clean it up so that the stack would exactly look like when you left it off. So if you say push PC and then here say pop PC, the exact 1005 address, that was the address of the PC when the PC had 1005 when you pushed it onto the stack. You'd want that value to be popped back inside the PC. We have an instruction. We don't have an instruction called pop PC, as we mentioned earlier. We have a set of instructions We have 4 pushes and 4 pops, and we talked about all of them. The instruction which is equivalent to push PC is actually something called return. So return doesn't have any difference with push PC. But here in the next lecture, now that you know the idea of why we need interrupts, we want to get back to the 8085 and first talk about all the different call instructions in 8085, and then move to the all the different return instruction. Return is just a pop, and call is a combination of push and jump. And finally, we talk about all the different interrupts in 8085. See you in the next lecture.